We're going to be looking at in-class notes. This is for 6E in-class notes. We're going to be working on more simplifying with rational and radical exponents. All right, so looking at the directions, we got to follow the directions because we're going to be asked to do different simplifying techniques with these expressions. All right, so we're going to rewrite as a simplified rational exponent. So rational is a fractional exponent. So here's the steps I'm going to follow each time when I go through this. I'm going to look at the coefficient, the 64 in this case, and think about rewriting it with the lowest base. With 64, I can rewrite with the lowest base of 2 to the 6th power. All right, then I've got x to the 12th y squared, and I'm going to rewrite that cube root as a rational exponent. That's my step 2. So I'm going to rewrite that as the 1/3 power. I'm going to apply my properties of exponent. So a power to a power, I multiply. So I get 2 to the 6/3, x to the 12/3, y to the 2/3. Now we're going to simplify the fractions that we can, and because our direction said to leave it as rational exponents, I'm going to leave it with fractional exponents. I'm not going to change it back to a radical. So 6/3 reduces to 2, 12/3 reduces to 4, and 2/3 is reduced. So my final answer in this case, 2 squared is 4, x to the 4th, y to the 2/3 is my simplified answer. All right, rewrite as a simplified radical. Because we have an improper fraction here, 9/5, that means that I can rewrite this. Some of my x's are going to be on the outside of the radical and some are going to be on the inside of the radical. The easiest way to think about this is if you rewrite that improper fraction as a mixed number. So 9/5 is 1 4/5. So I can think this is x to the 1st times x to the 4/5, which can be rewritten as x, the 5th root of x to the 4th. Because I had one grouping of 5 in my set of 9 x's. All right, here, we are allowed to only have one radical, so I have to get a common denominator. So the common denominator, the least common denominator between 2, 3, and 4 is 12. So 2 times 6 is 12, so 1 times 6 is 6. 3 times 4, so 2 times 4 is 8. And then 4 times 3, so 5 times 3 is 15. All right, I'm going to rewrite this as a radical. All right, because this is an improper fraction, I'm going to rewrite that as a mixed number. All right, don't reduce your fractions, otherwise you start over again. Your whole goal is to get a single radical. All right, 15/12 is 1 3/12. So now I can write it back. All right, so big radical with 12 index of 12. We got 3 to the 6th, x to the 8th. We've got a y on the outside because y to the 1st, and then y to the 3rd on the inside. And then finally I can rewrite 3 to the 6th as 729, x to the 8th, y to the 3rd. And that's my final answer. All right, what if we're dividing? Since they're both under a radical of 3, I'm going to rewrite that as the 1/3 power. All right, I'm going to look at my coefficients. Does 24 go into 192? Well, it does in this case 8 times, so divide it if you can. X to the 6th, y to the 4th over z to the 9th. All right, 8 I can rewrite as 2 to the 3rd power. All right, so I have a power to a power. I'm going to multiply my exponents. Now you may start simplifying as you go. I'm showing you every step, so hopefully I won't lose you along the way. All right, now we need to simplify as needed. So 3/3 is 1, so that gives me 2. X 6/3 is 2. y, 4/3 is 1 1/3, so that's going to get simplified over z to the third. All right, since I started as a radical, I want to end up with a radical. So my final answer is going to be 2x squared y, the cube root of y to the first over z to the third is my simplified radical answer. We can do similar by multiplying 2. We're both underneath the square root. So I can combine these. 32 times 2 is 64. X, since I'm multiplying, I'm going to add my exponents. So 6 and 3 give me 9. And y, 3 and 4 give me 7. All right, that's 64. I'm going to rewrite that as 2 to the 6th power, x to the 9th, y to the 7th, and I'm going to raise that all to the 1/2 power. All right, apply my properties of exponents. I'm going to get 2 to the 6 halves, x to the 9 halves, y to the 7 halves. All right, let's change it back into a radical. So what am I getting? 6 halves is 3. I'm going to think about 9 halves as a mixed number of 4.5, and 7 halves is 3.5. So when I write this back, 2 to the third is 8. I get x to the 4th on the outside, y to the 3rd on the outside, and then underneath my square root, I have x to the 1st, y to the 1st. So that's my final answer. All right, rationalizing. All right, we're not allowed to have radicals in the denominator, and we can't keep that cube root down in the denominator. All right, so what I'm going to do with this is rewrite it with rational exponents. 4 I can rewrite as 2 squared, and then I raise it to the 1/3 power, so that gives me 2/3 on the bottom. So my goal, through multiplying, is to get this denominator to be 2 to the 3/3, because 3/3 is the nearest whole number to 2/3. So that means, what do I need to get 3/3? I've got 2/3. That means I need another 1/3. So I'm going to multiply the denominator and the numerator by that 2 to the 1/3. All right, let's simplify. My numerator, because I have the 1/3 power, I can multiply 2 and 3 and get 6 to the 1/3. Let's change that back to a radical. So the cube root of 6 over 2, 3/3 is 1. So it's going to be the cube root of 6 over 2. It's going to be my simplified answer. I can do the same thing when I have variables. So I'm going to rewrite this as x to the 2/3, y to the 1/3. So here again, I've got to ask myself, I want to make this 3/3, y to the 3/3. So what do I need? I need another 2/3. All right, so my numerator this time, x squared, y squared, all to the 1/3. So when I change this back, I'm going to have the cube root of x squared, y squared over y. And that's my final answer. All right, try the practice, check your answers, and let me know if you have any questions.